Hello, I'm Thravalou. Now we're presenting an 8-beam driven simulation method for developing energy retrofit design scenarios on behalf of the rest of the team, George Artopoulos and Christis Alexandrou, who are also present today. So let's start with an introductory note that the protection and safeguarding of culture of built heritage is in line with the sustainable development goals. Heritage buildings occupy a very large part of the existing building stock, especially in Europe. But when it comes to the energy retrofit of this building stock, there are certain challenges that need to be addressed, and these have to be with the compatibility of heritage significance, technical compatibility in terms of materials and systems, as well as financial aspects. This is why retrofit guidance and decision-making tools are all under an ongoing development, and they aim to bridge the gap between the regulatory and the practical exemptions regarding the energy performance of these buildings. Using BIM technology provides great advantages in this aspect, because it brings together all the involved parties and also addresses aspects of sustainability and time management. As already mentioned, the BIM project aims at strengthening the use of building information modeling to enhance energy efficiency in buildings. Here you have a schematic representation of the methodology adopted. More specifically, you can see the surveys and the analysis denoted with the letter A that provide the necessary data to create the H-beam model in the H-beam platform. And in the same way, data from the dynamic energy simulation of the building exchange data with the H-beam platform in order to propose and conclude on the design of the energy retrofit strategy. As mentioned earlier, of course, the overall aim and objective is the pursuit of private funding through the energy performing contracting. In this presentation, we will focus on mainly the second milestone of this methodology, which is how to define the energy retrofit proposal through the 8-beam platform and process workflow. Here you have a more detailed analysis of the particular tasks that are involved in each methodological step, but let's see a little bit more in detail and examples through the case study of Cyprus. The pilot case study that was selected is a building located in Nicosia. It was a former Calvary club, and today is in a ruined condition. Here you can see some the spaces that are highlighted in red are going to be demolished as the building is going to be renovated, and additional spaces will be added after the renovation, here highlighted in blue color. So as a very important first step in the part of the building analysis and documentation, the building survey is the building survey. In our case, we conducted photogrammetry to create the 3D point cloud and succeeded in a high level of accuracy with up to 2 centimeters of accuracy. The conservation state analysis and the generation of thematic maps from the 3D point cloud is also another task. Of course, the climatic analysis that, beside the temperature, humidity, and wind data of the site, also involves microclimatic analysis of solar shading and natural lighting distribution. Indoor environmental monitoring is particularly important in the case of heritage building. In our case, we conducted the measurements of thermal transmittance and through the thermography we identified the stratigraphy and the building materials, the rising damp and the humidity, as well as we measured the acidity of the interior coating. Outdoor environmental monitoring is also a very important step, and it can be particularly useful in the step of the stage of model calibration. In our case, we installed the weather station in the vicinity of the building, that you can see here. Having all the data already documented, we incorporate this data in the HBIN model, and this data may have to do with space attributes, so operational schedules or HVAC schedules, or the thermophysical properties of the building materials. Of course, all the historical phases are also modeled with great detail. And passing on to the energy performance assessment, which was the second milestone that we're focusing on, it is important to have a clear goal of what is the objective of the energy renovation. One goal could be a short-term one, which includes ephemeral and cost-efficient interventions. A middle-term goal could also involve the renovation of HVAC systems and correspond to deeper renovation, while a long-term goal could potentially pursue the target of nearly zero energy building. In our case, again, as mentioned, we have a ruined building with limited spaces that were airtight. As mentioned, it's going to be renovated and additional spaces are going to be constructed. So in our case, the base case model and scenario that we're working with is a building with additional spaces, with double glazing and efficient heat recovery systems. Passing on to the energy simulation, we have selected energy class through the platform of Design Builder. As you can see here, the modeling, the model geometry has been incorporated, imported from the BIM platform in a considerably accessible way, with, however, some necessary simplifications and assumptions that we needed to make in the geometry. The best practices and the geometrical conversion have been documented and will be soon accessible to the public as they are under publication. So in this interoperability and data exchange process, several data were successfully interchanged between the two softwares through the GBXML schema. However, there are certain type of data that mostly refer to space and zone elements, and lighting, natural ventilation, internal gains, and HVAC systems that were not able to be exported. For this reason, we developed an alternative path for this data exchange, and for this reason, we used the CSV files, Excel files, simple files, with the application of Dynamo that is incorporated in the Revit, in the BIM platform. Having all the data already set for the simulation, for the creation of the model for the dynamic energy performance, a very big step, crucial step, is the model calibration. Depending on either we have or not HVAC systems, data for the model calibration can derive from energy bills or field monitoring. There are several indicators in the literature that can be used in this step. Also, the dynamic energy analysis provides us with very useful tools for the parametric analysis, the optimization, as well as the uncertainty analysis and the sensitivity analysis. For example, this is the matrix of design variables that we used in our case for the sensitivity analysis, and they concerned parameters on the envelope, the systems, and the infiltration. The results highlighted which parameters have the most prominent impact on the energy consumption, and running the first simulations, we have a better understanding of what is the pattern of the energy consumption in our building. So we have a clearer view of the cooling, heating loads, the equipment, and the lighting. And passing on to the assessment of the energy retrofit scenarios, as we said, apart from the saving in the energy consumption, there are several criteria and aspects that also need to be taken under consideration. This has to be with the compatibility of heritage significance, technical compatibility and feasibility check, as well as other design criteria and environmental sustainability aspects. In our case, for example, in the long-term scenario that incorporates the installation of renewable energy systems, we opted for the installation of photovoltaic panels on a separate construction that is the shelter of the parking at the back of the plot. And in this way, there was no conflict with the architectural integration of this shelter, of this construction. According to the results, 45% of the building's energy needs are covered by the renewable energy systems. And passing on to the techno-economic analysis of this strategy, we have some results that correspond to the total primary energy of 154 kilowatt hour per square meter. And considering the national threshold for nearly zero energy, which is lower, we understand that there are certain limitations when it comes to pursuing this target when it comes to heritage buildings. So as a conclusion, some concluding remarks is that yes, a set of guidelines and methodological compromises on how to use HBIM procedures in heritage buildings are necessary, and this will be the main outcome of BIM project. However, given the complexity of built heritage, the case-by-case approach is also needed and should be regarded. Also, in terms of interoperability between the two softwares, we realize that this is still a semi-automatic workflow. If we want to have more accurate transitioning of the building geometry and the metadata, further development of the exchange schema is necessary. Finally, this integrated methodology that was presented here is a useful decision-making tool for designing the energy retrofit strategy, given the specificities of the built heritage. However, it can be applied to the wider existing building stock. So, thank you very much.